Good afternoon. This is Professor Arnold here, and today I will show you how to construct an interval for a confidence interval for a proportion. I will do this by an example. So here is the example. The proportion for a sample of 50 subjects is 0.44. All requirements for a confidence interval are met. Construct a 90% confidence interval. We talked about the requirements before. For all procedures, there are requirements. The requirements refer to the assumptions and conditions. So to make life easy and so that we can just concentrate on how we actually calculate the confidence interval, we're not going to discuss the requirements at this time. Okay, so we have three methods we can use to find a confidence interval. One method is to find the standard error, the critical value, and the margin of error. I will explain these as we go along. The second method is to use inverse norm. And you know, inverse norm is you're given an area and under the normal curve, and you're trying to find a z-score or a data value. We do this on the calculator to find values to the left of alpha over 2 and to the left of 1 minus alpha over 2. Alpha is the margin of 1 minus alpha is the margin of error. So for right now, just write down these values for me. Write down n equals to 50, p hat equals to 0.44, and CL, which stands for confidence level, equals to 9% or 0.90. Write those down. I'll give you 5 seconds. 50, 0.44, and 0.90. Okay. The final method is simply to use the calculator function that was designed just to find that, provided that you give it the inputs. And that function is z-prop int. Let's look at the first method. Again, that is just to find the standard error, the critical value, and the margin of error, and put them together. So just remind ourselves of the problem. The problem states that the proportion for a sample of 50, so n equals 50, we wrote that down. P hat is equal to 0.44, and construct a 90% confidence interval. So 90% or 0.9 is equal to 1 minus alpha. So write that down, 1 minus alpha. Okay, so going to continuing, this method can be done in 6 steps. So the first step is to draw a picture. And in that picture, what you would do is you will show alpha over 2 and ZR, or what we refer to as Z alpha over 2. Z alpha over 2 is simply the Z value corresponding to the point at which the area to the right is alpha over 2. So let's see what that looks like in the picture. Draw your horizontal axis. Now we're going to have, even though I have one axis, physically, there can be 2 sets of units. You can have the x values as well as the z values. So on either side, I want to draw a line of the normal curve. You'll see I have alpha over 2 on the right and alpha over 2 on the left. So alpha in the middle is 1 minus alpha, and that's 0.90. So you can do some math and figure out what alpha over 2 is. So like I said, for the z-axis, you would have your z star or z alpha over 2. And for the x-axis, which we have the data values, you would have p hat in the middle. You would have LE. LE stands for left endpoint. So that's the left endpoint of my interval, and RE on the right. And that's the right endpoint of my interval. So in some books, or you may see in another video, you'll see that the person uses x1 for the left endpoint and x2 for the right endpoint. I mention it so that if you go to another source and you see a different notation, it's not like they are talking some different language. It's just that we use different symbols, different books, different authors use different letters to represent the same thing. So moving on, we'll see, remember we're trying to construct a 90% confidence interval. Step 2, you would compute or determine p hat and q hat. I say compute / determine because in this particular case, p hat is given, but sometimes they will actually tell you, what's the x value, the count of the successes, say, versus how many were in the sample. So, they say X subjects had such and such a property. So therefore, you have to compute p hat. In our instance, p hat was given. P hat was 0.4. Q hat, on the other hand, you always have to calculate. So Q hat is simply 1 minus p hat. So that's 1 minus 0.44, which is 0.56. I know you know how to do that. So let's go on to the next step, and that is to compute SE. Now, SE is the standard error. Think of it as standard deviations. Standard deviation. So if we know standard deviation, we know how many standard deviations a point is away from the center, then you can find the value. So that's what we're going to do here. But instead of standard deviation, we're going to use standard error. And the standard error is the square root of the quantity p hat times q hat divided by n. So I'm going to give you a second. I know you have these written down. Remember you have p hat. Okay. P hat is 0.44 and q hat is 0.56. So plug that in and let's see what we get for SE. Okay. So you should have something that looks like this. So I rewrote it this time. The quantity 0.44 times 0.56 over 50 raised to the 0.5. That's the same as finding the positive square root. And that's going to give us 0.07019. So you need to write this number down, 0.07019. Okay. And then we go in and find the critical value. This one we have to compute. And it's simply z value corresponding to where you have an area of alpha over 2 to the right. So you can use inverse norm. So you can use inverse norm of 1 minus alpha over 2 or minus the inverse norm of alpha over 2. In other words, by symmetry, we go over to the left side, we find the area, the point at which the area is pi over 2 to the left, and then take the opposite to get the z score on the right side. Write this number down. We get 1.64485. So we wrote down those two numbers, which were SE and Z star. I'm asking you to write them down because the next step is going to ask you to multiply them. The next step is called the margin of error. And the margin of error is simply E equals to Z star times SE. Plug in those two values that I asked you to write down in. You see that E is equal to 0.11545. So now we are in a position to find the confidence interval, which is the last step of method 1. So the confidence interval by definition is p hat minus e as the lower endpoint, comma, p hat plus e as the right endpoint. So hopefully you wrote down what e was. So ci is equal to 0.44 minus the e. We got that from the previous slide. And on the right side is 0.44 plus the e, same value. Finally, we finish up and we say, oh, the confidence interval is 0.32455, 0.55545. Notice that I'm always using 5 places. And the reason for that is most of your problems are going to ask you to round to 4 places. If you're going to round to 4 places, you have to work in 5. You cannot work 5 some of the time. You have to work in 5 all of the time. So now at the very end, you will round it to 4 places. And in this instance, this is what you will get. Now, the confidence interval can be also written as p hat plus or minus e. So depending on the format they are asking you for, you will write the answer accordingly. So here's the other way to write that. Now, if they ask you to round to 4 places of decimal, it means if you write it in this format, both numbers have to be in this to 4 places of decimal. Of course, 0.44 and 0.4400 is the same thing. So with not writing the 0 is not a big deal. Okay, so we're in a position now to find 2. Method 2, like I said, is just to find the inverse norm of the area to the left of alpha over 2. You have to refer to the picture to understand where the alpha over 2 is coming from. Remember, there's alpha over 2 on the left. So one of the endpoints is right there. So all I have to do is find inverse norm of that value, alpha over 2. And in the case of the other point, which is on the other side, it will be, that area would be 1 minus alpha over 2. So you plug those two, and they will give you the left and right endpoint. So again, you see we get the same value for the left endpoint and for the right endpoint. So we have the same value for the confidence interval. So we have 2 methods of doing it so far. So now we're going to float into method number 3. This is just to use the calculator function, which is called Prop ZINT. And this function is built just for finding the confidence intervals of proportion. So all you have to do is find it and plug in the values that it needs. So here's how you find it on the calculator. You go to Stat, then you arrow over to Tests, and there are a series of tests. So they are numbered like 1, 2, 3, 4, 5, and so on. When it gets to 0 and there are more, it goes like A, B, C, you know, like hexadecimals. It's like that. So at the A position, the function is 1 dash prop z int, and it's going to ask you for the arguments. All functions take arguments. So x is 22. I know you're wondering, well, where did the 22 come from? We never had 22 before. If you look back at the numbers that I asked you to write down, there was never a 22. So we'll talk about that in a second. N, we know, because n is 50. You just look at your little sheet that you wrote down in the book. So it shows that we're not inventing anything. The C level is 90%. And then finally, you'll hit calculate. So let me talk about 2 things here now. Let's talk about the 90. When we were doing the problem the other way, the very first method, we changed the 90 to 0.90. If you are using the calculator function, you do not change the 90% to decimal, you leave it as 90. If you use the decimal, you'll get a real screwy answer. Okay, so now let's talk about x being 20. Well, the calculator wants x and it wants n. Okay, it has to make a decision. Either it wants p hat or it wants x over n. So the decision they made was to use x and n. So you would have to calculate x. Professor, how do we calculate x? Well, you know how to calculate hat. P hat is x over n. So do a little bit of algebra, you get x is equal to p hat times n. So that would be 50 times 0.44, which will give you the 22. All right. So note the results. Once you plug the values in and you hit calculate, it will give you the results like this. And that would be the answer. So notice that x must be a whole number. Sometimes if you do this calculation, you would find that you will get, say, 47.7. Well, if you put 47.7 for x, you would be there all day trying to figure out why it's giving you an error. And you'd never know why it's giving you an error. That's the reason, because it doesn't take decimal. So you'll have to round it. Now, if everybody rounds the same way, we'll all get the same answer. If you don't round properly, you will get a slightly different answer, most likely in the third and fourth decimal places. Okay? So, a couple of notes. So, one of the hardest parts of doing all of this, especially using the first method, finding the z value. So here I'm going to show you how to find the z value for 95% confidence interval. Again, you would find alpha over 2. Remember, it's 1 minus 0.95 divided by 2. So that case would be 0.025. You take the opposite of the inverse norm of that, and that will give you your z star, or your z alpha over 2. Now let me do that also for 99%. For 99%, the alpha over 2 would be 0.005, and plugging that in for your z into the minus inverse norm, you will get, didn't do them. So I'm leaving those for you as exercises. And that brings us to the end of this. So ladies and gentlemen, I appreciate you hearing me. If you find that this was a bit fast, no problem. Just start the video again, pause it, stop it, pause it, do whatever it takes for you to learn it. I appreciate your attendance. Talk to you again. Bye.